Okay, you've made it to the independent practice, and ideally, you're doing most of this on your own. However, they're asking for something a little bit extra in this independent practice, so I wanted to make sure that you could follow through and do some of these problems. So it says here, Gilberto decides to give a t-shirt to each of his sponsors. Each shirt costs him $4.75. He plans to pay for each shirt with some of the money he raises from each sponsor. So for everyone that is sponsoring him, he's going to give them a shirt that will cost $4.75. So that will be taken away from his total or subtracted from his total. We need to write an equation that represents the amount of money Gilberto raises from each sponsor after he has paid for the t-shirt. So it's after he has paid for the t-shirt. So we need to really think about, how are we going to write an equation that accounts for that? Explain what information each number and variable represents. So we know his money is going to be something we're calculating. So I'm going to choose to put money is M. You can choose whatever you want. Some people say A for amount, T for total, whatever it is you want. Just make sure that you are labeling what is the money in your situation, or amount raised, or whatever you want to call it. Another thing is that we know his money is dependent on how far he walks. We know that from the previous parts of the problem. So all the money he makes depends on how far he walks, and that's measured in kilometers. So I'm going to say K stands for kilometers. So I know that my equation has to involve money and kilometers. And the only thing I'm really doing is adding it to this idea that he's going to be paying for a t-shirt that's $4.75. So if you recall, in the past, we wrote a very similar equation to this where he would have the money that equals, remember, he makes $2 per kilometer, right? But now you just have to think about, what could I put here, right, that would take away the cost of the shirt. So you're not done with this equation. You still have a little bit to finish up, and you need to take away the cost of the shirt in the rest of this equation. I'm going to let you fill in the rest of that, and then talk about number 2. So you can pause here, try to fill that in, because you won't be able to go on to number 2 without filling that in. So in number 2, you're going to graph the equation for the distances from 0 to 5 kilometers, and you're going to compare this graph to the graph of Gilberto's pledge plan in question A. So part 2. So here's what I'm going to suggest. This is the graph I've chosen to make. I went by 2's on the y-axis, and you can see that the big difference here is I've drawn some negatives. And the reason is, if he doesn't walk at all, he's going to have spent $4.75 for each person. And so I need to have some negatives show up on my graph so that I can graph where it's going to be a negative amount, where he would be losing some money. So when you have created this equation, all right, you're going to plug in these points and then graph it from there. One thing I'm going to point out is we all know that if he walks 0 kilometers, he's not going to have earned any money at all. So he's going to be negative $4.75. Since halfway between 4 and 6 is negative 5, it's not quite there, so I'm going to put my dot right above that, just almost at the halfway point between negative 4 and negative 6. So I'll tell you for sure, that is going to start there, because he's going to be negative 475. And then I'm going to let you use your equation and what you know about how this problem works to help you, for you to help yourself fill out the rest of the points. And you don't have to use the same scale as I do. I've just found that this will get all the points on that you want. And then you need to decide, is it a linear relationship? So does it form a straight line? And explain how you know that or how you saw that. And remember, we can't all draw the lines perfectly. You're not a machine. So